Hi friends, the next issue to look at is when a graph is given, how can we convert a graph into a tree? Tree is a structure which has got a set of vertices and set of edges as the graph contains, but the difference between tree and graph is in tree there will not be any loops. So no loops are present in the V. That means there won't be any closed loop. So in our tree, if you look at it, then we can see from 2 to 7, 7 to 5, 5 to 4, 4 back to 2, there is a loop. From 1 you can go to 6, from 6 you can go to 2, from 2 you can go to 3, from 3 you can go back to 1. Yes, there is a loop. So this graph is a general term where tree is a special form of a graph which doesn't contain any loops. Now the question is how to convert a graph into a tree. So graph can be represented as human friendly version in the form of a graphical way, or machine friendly version, which is adjacency matrix. So how can we convert a graph into a tree? So basically there are two ways of doing it. One is breadth first version. So check breadth wise or check depth wise. So when you say tree, yes, we have discussed trees in our earlier sessions, that it goes a root. A root is there, and then different intermediate nodes are there. Finally, leaves are there. So root is on the top, leaves on the bottom. In between, there will be intermediate nodes. And one thing very clear, there won't be any interconnection making a loop. So there is always a direct path from root down to the leaf. So for to a leaf, there will be only one connection, cannot be more than one connection to a leaf. If there is more than one connection, then there will be possibility of having a loop. So we look at how these two work. So breadth first means it works level wise. Depth first means it goes in a series one after other. So let's look in detail one by one how they are done. So looking at a adjacency matrix. So let me begin with node 1. So when I'm looking at node 1, then I can see that node 1, there is connection to node 3, and there is a connection to node 5, and there is connection to node 6, and finally there is a connection to node 7. 3, 5, 6, 7 are ones in this, so we made it. Okay, so that's the first step. Then go to 3. So from 3 where all we can go, so 3 to 1 we already marked. Then we can go to 2. Yeah, 3 to 2 we can go. Anything else? Nothing. Then 5. From 5 we can go to 1. From 5 we can go to 4. Okay. From 5 we can go to 1. From 5 we can go to 4. From 5 we can go to 7. So 5, if I put a 5 to 7, then you can see there is a loop for me, therefore this is not allowed. So we need to remember that 5 to 7 is not allowed. How to do? Let's check that in a short time. Okay, then comes 6. From 6 you can go to 1, connected. From 6 you can go to 2, no, it forms a loop, so will not use. From 6 you can go to nothing else, over. So from 7 you can go to 1, from 7 you can go to 2, 1 is already connected, 2 you cannot connect. From 7 you can go to 5, which also not possible. So then from 2 you can go to 3, 4, 6, 7. 3 you can't, you already connected. 2 to 4 you cannot connect, but forms a loop. 2 to 6 cannot be used, forms a loop. 2 to 7 cannot be used, forms a loop. So none of them can be added. Then coming to 4, it can be connected to 2 and 5. 2 cannot be connected, 5 is already connected, so that's it. So we have built a tree where all nodes are present. 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, 7 is there. All are there. And what we have done is we have checked row wise and went on connecting. And second thing is, if you get it again, so duplicate nodes not allowed. So that means once we had used 2, again anywhere other place, if it is trying to connect it to, you say not allowed. So that's what I meant. Okay, now let's see the other version, which this is what we called depth first. Sorry, breadth first. Because we went on adding breadth wise. So 3, 5, 6, 7 were added, and then so this way we are adding, therefore breadth is used. Now if you go for depth wise, then what can we do? Let me begin with 1. So what comes first? A 3. So let me write a 3. Okay, after 3, go to 3. 3 to 1 already used. 3 to 2. Okay, then go to 2. 2 to 3 is used. Then 2 to 4. Done. Then go to 4. Go to 2 is done. 4 to 5. Then go to 5. 5 to 1 is done. 5 to 4 is, 5 to 1 cannot be done because that makes a loop. Then 5 to 4 just now we added. Then 5 to 7, yeah, you can go for 7. Then go to 7. 7 to 1 cannot be used because it makes a loop. 7 to 2 cannot be used because that makes a loop. Then 7 to 5 is already connected, so that's it. So 7 to 1 is over. 72 cannot be done. 7 to 1 cannot be done. 72 cannot be done. 75 cannot be done. So that's it. So did we get all the nodes? 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is missing. Okay, then where should I connect 6? 6 is connected either to 1 or 2. So you can connect it from 1 or you can connect it from 2. So that makes depth first one. Here we take first element or first valid element each row to continue. So started with 1, first row, then first element we got I is 3, and which is possible, so we went to 3. Then go to 3, first element was 1, not possible, because if you make 3 to 1, then it makes a loop, so did not use. 3 to 2, yes, possible, used. Then go to 2, 2 to 3 not possible, 3 to 2 to 4 possible, so add 4. Then go to 4, 4 to 2 not possible, 4 to 5 possible, so add 5. Then go to 5, 5 to 1 not possible, 5 to 4 not possible, 5 to 7 possible, so add 7. Then what is remaining? 6 is still remaining, therefore you go back to 5 and see anything is left. 5 to 7 we did, so nothing possible. Then go back, then try from 4 anything possible. 4 to 2 we have cannot do, 4 to 5 we have done, that's it. Then go back to 2 and see 2 to 3 not possible, 2 to 4 we have done, then 2 to 6 cannot be, 2 to 6 is not yet done, and doing this you are not going to create any loop, so add it. So that's a logic. So how did we work on this? So if you just look at the logic of working this one, we started with first row, and what all are one in the first row, we just added them one after other. All of them in the first row are added whose value is 1. Then the first element which was added is extended. So from 3, if you look at it, there is only one possibility. If there were more possibilities, we could have got more from 3. Same way from more from 5, more from 6, more from 7 may be possible if there's possibility was there. It was not possible, so we couldn't write, but yes, it is possible. So what we did is, after 1 is done, all possible things are listed, and then the first one which was listed is extended again. Then second one is extended, then third one is extended, then fourth one is extended. After this last one is extended, we go to the next level and start again from the first one which was added in the next level. So this is something to do with the first come first serve or first in first out logic. So this best can be implemented using first in first out logic, which is a queue. Now this side we started 1, then we went to 2, 3, then to 2, then to 4, then to 5, then to 7. And when we found that from 7 we couldn't continue, then we came back and tried anything left from 5. Nothing was left from 5, therefore we came back and looking from 4, anything left, nothing was left. Then we came back to 2 and tried to see anything left. Yes, we realized that 6 is still to be added from 2, so we added from 2 to 6, and then went back to 3 and tried anything is left, no, then went back and tried anything left from 1. So we started with 1 and went forward and then returned back to 1 again. So this something to do with the first in last out activity, where stack is a best data structure useful in this type of activity. Queue is the best data structure useful for this activity. So there are two possible ways of converting a graph into tree. Depth breadth first version using a queue, first in first out logic, or a depth first using a stack, first in last out logic. So more details of implementation of this will follow in the coming lecture. So keep watching, don't miss. So thank you.